Another way of solving a system of equations is by the substitution method. If one of my equations is solved for a variable or is easily solved for a variable, substitution is a good method. In this case, the y is equal to 3x minus 4. So we're going to take the 3x minus 4, substitute it in for the y on our second equation. So in our second equation, we have 4x plus 3, and we're going to replace the y with the 3x minus 4 equals my 27. Now I have an equation that just has one variable that I should be able to solve. So 4x plus, using my distributive property, 9x minus 12 equals 27. 4x plus 9x would give me 13x minus 12 equals 27. Adding my 12 to move it over, 13x equals 39, and dividing, x ends up being equal to 3. Once I find x, I still need to find y, so I can use that top equation that said y equaled 3x minus 4 and replace the x with my 3 that I found. So 3 times 3 is 9. 9 minus 4 gives me 5. If I wanted to double check and make sure that was right, I would check it in my second equation. I'd say is 4 times 3 plus 3 times 5 equal to 27. 12 plus 15 is 27. Yep, checks out. So I know those are the right answers. So, number 11. This time my second equation is set equal to x, or x is set equal to 3y minus 18. So this time we're going to replace the x in the first equation with the 3y minus 18. So what would we have for our new equation? So multiplying that out, we would get combining my like terms, adding my 90, and dividing. It's 95 divided by 19. With 9? 5? Can't hear you. 5, okay. By the way, I'm Alex. These will all come out to nice whole number answers, so you won't have to worry about having some weird fraction answer like you might in a textbook. So if you are getting a weird fraction answer, go back and check your work. I knew y was equal to 5. I still need to find x. So I know that x equals 3y minus 18. If I put 5 in for my y, x then is going to equal negative 3. 15 minus 18 is negative 3. Sometimes you have both of your equations in standard form, but you'll have a variable with the x or the y that doesn't have a coefficient other than 1. The leading coefficient is 1, so it's easy to solve it for x or y, and therefore substitution works. I still probably use the elimination method, but substitution works. So what I need to do is I need to set this one equal to y by moving my 3x to the other side. So that's going to become a positive 3x minus 5. And if you put negative 5 plus 3x, still going to work out okay. But look for one that doesn't have a coefficient other than 1 in front of it and solve it for that so you don't have any weird fractions. Substituting in for y then, my new equation would be 12. Okay, multiplying 2x minus 15x plus 25 going to equal 12, right? 2x minus 15x would give me negative 13x plus 25 equals 12. I'm going to minus my 25, so negative 13x equals negative 13. So x is going to equal 1, right? I figure you guys know how to solve. So x is equal to 1. I still need to find my y value. Over here we solved for y. We said y was equal to 3x minus 5. So if x is 1, y is going to be negative 2. And again, if I just quickly check it, 2 times 1 is 2, negative 5 times negative 2 is 10, 2 plus 10 is 12. Yep, it checks out, so I know I did it right.